All right, so we're going to look at number 18 from our practice test. And if you've been watching along, we're going to come down here. It is question 3.1.9. So it's from section 3.1 in our textbook. We're looking at a table of values. So the table below shows the gold medal Olympic times in seconds for the 200-meter run. Data are shown for 4 of the first 5 Olympics of the 1990s and 4 more recent Olympics in the 2000s. Complete parts A through C below. All right. So we have year and time. This is 1900s, 4 out of 5. We have year and time. These are our 2000s, 4 out of 5. Part A says find and interpret. So we're going to report in context the mean and standard deviation of the winning times for 4 of the first 5 Olympics of the 1900s. So that means we are only using, let's try and highlight this, this, and this. So this is going to be our data set that we are going to use. Now I have the calculator here because we're going to use the calculator to find these values. So what we want to do, we want to find the mean and standard deviation, and it says for the 1900s. So that's what that is. We're going to select the correct interpretation of the mean below and fill in the answer box. Okay. So to find the mean, I have this instruction. So this came from a document that I added to that resource section in Canvas. So make sure you can look for it, make sure you have this and you know how to use it. We are doing descriptive statistics. So I'll make it a little bigger. Let me maybe zoom in. That's great. Descriptive statistics, mean, standard deviation, minimum, Q1, median, Q3, and maximum. So this will do everything we need for this test. So what we're going to do is we are going to insert our data into our calculator. And then we are going to do stat calc 1var stats. I'll show you how to clear a list, and yeah, we're going to read these things off. So that's all we need to do for right now. Okay. So what I'm going to do to enter data into my list, I'm going to clear this out. Okay. So to enter it, I'm going to do stat. I'm going to edit. Now, if your list, I'm just going to put some data in here real quickly. It is good practice to just clear it out at the beginning. To do that, go up all the way to L1 at the top. Okay, so we want to clear our list 1 because that's what we're going to use, right? So when we're clearing L1, you go up to L1, you're going to hit clear. So you see all those values went away right here. You're going to arrow down, ta-da, it's all gone. It's like magic. Okay. Now that we have that, the next thing we want to do is enter the new data. So we have 22.2. We're going to do 22.2. Look, it has L sub 1. So it's going to be it's an L1 sub 1. So that's the first entry in our L1 column. Hit enter. Next, the second entry, we're going to do 21.6. So that's our second observation. We have 21.7. And last, we have 22.0. I'm going to hit enter. Now, I mentioned this to some people in this study session earlier. This number 5 here, that's where we are. A good way, so see you have a lot of data. Take this -1, that's 4. I had 4 entries. Okay, I feel pretty good. This is a small data set. I'm going to just double check it. 22.2, 22.2, 21.6, 21.6. 21.7, 21.7, 22, just to make sure. And you'll get a sense pretty quick if you're good at this or if you make mistakes. Just, notice where your errors are and, make sure that you're double checking and correcting for those. Sometimes I get tired. I type things funny. Sometimes on the computer, I know that I may accidentally hit the wrong thing. So I like to double check. Once that's done, so that was the first part. We entered our data, stat and edit. We picked our list. So we can go ahead now. Stat, and we are going to calc, and we want the 1 variable statistic. So we only have 1 variable that we have measured, and it is the time. Okay, so I'm going to go to stat. Calc is, so we're in the edit menu. There's a calc menu and a test menu. We're going over to the calculate. 1 variable, 1 var stats is the first choice. You can pick one or you can pick enter. I'm going to hit enter. And then we have our list for L1. So that's where I put my data. You want to make sure, oh goodness, what did I do over here? Okay, so you want to make sure that you keep that list. So if you put data in L2 or L3, you would need to change it. To change it, You can either select L1, L2, L3 down here with the keys. You're using the blue sub menu. So say I wanted to change it to L2. I'm going to use the second, which is my blue key, right? I'm going to push L2 and now it changes to L2. So say you come in and it's L1, you do need to arrow over to it because if you put it next to it, you'd have to delete it all, which is fine. But you're going to go second and then it's number 1 gives you L1. So to pick that blue menu, you're going to use your second key. We're not doing a frequency list. We're going down to calculate. We're going to hit enter. Okay, so this gives me my X bar. It gives me the summation. It gives me the summation of X squared. That's the sum of squares. We have our S, our sample standard deviation, and we have our sigma. That's our population standard deviation. That's our population data. So what we need to do now, because this is 4 out of 5, we know that it is the typical winning time for 4 out of the first 5 Olympics. Oh, wait, that's not the right year. So let's not pick that. Let's do part C, the 19. Oh my, I got really excited, I guess. Let's not do that. Let's just do the 1900s. So that's the correct one. Now I had a text box. I may have lost him. Let's put a new one in. I'm gonna grab a little text box. I'm gonna put it here. Maybe. That's why I had him ready because he wasn't cooperating so well earlier. Let me just double check my settings. Okay. See if I can insert my little text box. Where did you go, friend? Okay, well, I'm going to try my best. What I'm going to enter into this box, if I can't do it, we're not going to stress, it's going to be the 21.875. Now, we have been asked to type an integer or a decimal rounded to the nearest hundredth as needed. So what I'm going to type in that box in that case, 21.875, the 7 is going to round up, it will be 21.9, okay? I'm going to see if I can make this go away. Maybe that's what I did. Put my box here for me. I'm not sure why it's not working. It just worked a second ago. Maybe I just. Okay, so let's try this one more time. Let's try my text box. Okay, well, we know what to do. So that would be 21.9. So you would just round that. Okay, let's go down to the standard deviation and then we'll figure it out. So 21.8 was our first little box, which rounds to 21.9. That's why I need my box. I'm gonna pause this real quick and see if I can figure it out. Okay, I figured it out. I was saying the wrong thing. This one's the text box. I'm not sure what that other box is. So I'm gonna come over here, do it one more time. My little text box. I'm gonna grab this guy. He's gonna go right here. So it'll be 21.9, and it needs to not be white, right? So let's change this color to, we'll go with something that matches my beautiful pink. All right, so 21.9, and these would be, I assume, in seconds. Yes, that's some interesting font there. It's fancy tonight. Okay, so let's pick this, maybe make it bold so you can really see it. Excellent. Okay, standard deviation. We're still using the pink. So standard deviation of the winning time. So the first of the 5 Olympics in the 1900s is. So I'm going to do that after I do the next text box. We'll move that. So let's go ahead and put this text box down here. So standard deviation, we're using the sample. So if it's 0.2735, we're going to round up. It's going to be 0. Oops. Just kidding. It's going to be 0.28. Let me double check that one last time because now I'm getting nervous because my memory is not the best. Let's just do it one more time. It was in L1. We're just going to arrow down, double check what I told you. So yes, because we rounded up 275, the 5 rounds up to 8. Okay, I just wanted to make sure because I didn't want to have something incorrect and you all to be confused. So now I'm going to highlight this as well. I'm going to highlight, so that would be the B choice and it's the 4 out of the 5. Okay, excellent. Coming down to the next one, we want to do the same thing, but now we're going to do it for the 2000s. So we will be using these 4 data values, okay, for 2000s for part B. So the more recent Olympics are the ones that occurred in the 2000s. the mean winning time. So we're going to go here, and now we're going to go back and plug our values in first in order to find our mean and our standard deviation. So they didn't have you choose an A, B, or C. So we'll just put these texts in, and then we'll compare them, and we will call this problem done. So entering our data. So we'll go to our, get rid of second maybe. Let's go to stat. That's the wrong one. So second quit. Let's go to stat. Let's go over to edit. So we're on edit. Let's not move because we want to edit our list. Again, I'm going to show you, go up. And so this shows you the data values you have. We can hit clear. It's going to clear them all out. And then if you, I think you actually can hit enter too. Enter, or you can arrow down, whichever one. And now let's do 20.1. That's my first observation. We have 19. Whoops, 19. See, sometimes I type wrong. 0.8. Enter. 19.3. We're going to hit enter. And my last one is 19.8. Wonderful. Again, you know, there's 5 here, so that means we did 4 entries. Perfect. 20.1. I wonder if I feel like this is really small. Is there a way to? Oh, let's not do that. Sorry, y'all. Cancel that. I probably should not have hit that button. Cancel. Uh-oh. Okay, let's go back here and hope our data is still here. I was trying to make it bigger. We're just going to leave it alone, maybe. Yeah. So we have 20.1, 19.8, 19.3, and 19.8. So hopefully you can see that. If not, maybe you can like zoom in on yours. And I'll work on that for the next set of videos. Now what we want to do, same thing, we're going to go stat. We're going to go over to our calculations. We're going to do one variable stats. Our data, once again, is NL1. My dog is not happy. I've been doing this all day. And we have our mean of 19.75. So to round that, so coming down here, let me put my text in for that. And this time we want to change it to some sort of blue. This is very much, oh no. My computer's not happy either. It's like, we're all about to give up here. These are actually the last problems I'm doing because I decided to do the calculator ones all together. So everything has had a long day at this point, including me, the calculator, and my dog. He is ready to be done. So 19.8, excellent. Let's do one more box right here. So we'll just take this and we're going to move him down and put him on our standard deviation. We will be using the sample. So we're looking at 4 out of the 5 for that. So we know it's a sample. Okay, again, my computer. So that means we're looking at the S. So it is 0.331. So we will leave it at 0.33. So the 1 will not, you know, round down or drop, and that means dropping when we're talking about decimals. So now let's compare. So we want to evaluate this. This is where it becomes important. So compare the winning times from the early 1900s and the 1900s. So the winning time was 21.9 in the 1900s. The winning time was 19.8 in the 2000s. Which of these, so is the recent winners, are they faster? So are these faster or are they slower than that? What do you think? I'm gonna let you think for a minute. So if the people like are, I don't know, like that's maybe my grandmother, probably your great grandmother, 21.9, were they faster or slower than us? Or I said this backwards. So are we faster than them or are we slower than them? We're faster, right? So just make sure that you're thinking about it in the right sense. So the 1900s, they ran, it took less time. So that would translate into faster. Again, English language here, just make sure we got that part down because I know that can be sometimes interpretation, so faster. And which one has more variability? So if your standard deviation is larger, which it is for the 2000s, then that would have more variation. So the Olympics of the early what? Have less variation. So less variation would be the 1900s, right? Because they have less variation than we do now. It's smaller, which is less variation. So their data is a smaller spread. Let me put one more text box and it's the 1900s. So go ahead and put that in. And I think that's the end of our problem. All right. So we looked at question 18 from practice test 1, and this is question 3.1.9.